Hello, hello,
Good evening, sir.
good evening. Am I audible?
Yes, sir. Yes, sir.
Okay. So, will there be more person joining or should we start?
Good evening, sir.
Good evening. So, should we start or should we wait for a few more minutes?
It's depend on you, sir. Whatever you think is right, then go ahead.
Okay. I think, okay, yeah. So, it will be our first session. So, have you guys taken any more courses before that are registered in NPTL?
Yes, sir.
Okay. So, are you aware about like this kind of a doubt clearing session in NPTL?
Yes, sir. Yes, sir.
Okay.
Sir, this is my first time to join a NPTL course, so I don't know about. I don't not much know about the problem solving session.
Okay, fine. What
Mm.
about
Good,
others?
e-
There is one more.
Good
Okay, yeah.
evening, sir.
Good
This is
evening.
my first session too.
Okay. So, what you guys are doing? I mean, are you a student or what you guys are currently doing?
Sir, currently I am not doing job because I have got an accident. So
Okay.
that's why, sir, I'm at home. So just join NPTL course to
Okay, fine, fine.
remember my. Yes.
What about others?
Hello, sir. I
Yes.
am Alexander,
Hmm.
finally a student of Manet Bhopal.
You are a BTech student?
Yes, sir.
Okay. In which year?
Final year student.
Okay. So, department?
Department Metallurgy.
Okay. So, it means that your gate and all exams are coming soon, right? Next week, probably.
No, sir. But actually, in my college, there are intensive program. So uh, there are necessary to clear NPTL course.
Okay, okay, fine, fine. Okay. Yeah. And
Mm.
what about,
Good evening, sir. I
yeah,
am PhD student in ICT Mumbai.
ICT Mumbai. Okay, okay,
Yes,
fine. So which year PhD?
first year.
Okay. ICT means Institute of Chemical, right?
Institute of Chemical Technology.
Okay, okay, very nice. Hmm. Okay, yeah. So your area of work has defined or not?
Yes, sir. I'm working on nanomaterials towards energy storage devices.
Okay, fine, good. So yeah, this course will be, I think, good learning for you. Uh, So actually, okay, so let me give you my brief introduction before starting the session. So my name is Saurabh Soni, and currently I'm also a PhD research scholar, and I'm in my third year of PhD in the Department of Metallurgical Engineering and Material Science at IIT Bombay. So I'm a PMRF research scholar. So this session, most of this doubt and clearing sessions are of different courses are taken by all the PMRF research scholars. So this we have to do as a part of our teaching assessment externally. So yeah, this semester I will be your uh, TA for your doubt and doubt clearing session for this course. And every week on Tuesday in the same time, 7 to 9, this session will be there. So if you will have any doubt, or if you are facing any problems or whatever in the lectures, so you can come in this session at this particular time every week, and where we can discuss all your doubts and problems. So yeah, so I hope that I will, because I'm also learning this subjects. This is new to me, and but since I'm having a little bit background of in this course, since I'm doing research in this field, so probably I will try to solve your most of the doubts, and if not, then let me know. I will come prepare in the next class and try to solve your problems. So we'll go ahead week by week, and so yeah, one thing from my side will be like, it will be a good for you and good for me also, if you before session, if you watch at least 3 to 4 lectures, if not all, then at least have some ideas when we were discussing the problems, have some feel about the course and the module of every week. And apart from that, I will also have one request, because since you are now here are 3 people, but in my last sessions there were like more than 30 people. I hope to join in this semester also. So I mean, please be on time, because it will hinder, I mean, for my session also hindrance to keep on coming people, and I have to get them all admitted in between. So yeah, so that's all from my side. And if you have any doubt, then you can ask before starting the session. If not, then should we start?
Yes, sir, you may start.
Okay, yeah, fine. um, okay. So let me share my screen again. So, so I hope, can you guys see my screen in a presentation mode?
Yes, sir.
Okay,
Yes,
yeah.
sir.
Okay, yeah, fine, fine. That's good. So yeah, let's begin with our session, very first session, and this is week 1. And um, so welcome you all to the doubt and problem solving sessions of carbon materials and manufacturing. So again, myself Saurabh Soni, and I'm a PMRF research scholar at IIT Bombay, and we'll begin with this course. And this is a week 1, so I'm expecting that you have at least some flavor of this course, and hope you have watched the module 1. So these are some past questions and some related questions related to your module 1 that I'm able to collect, and which I will be discussing in this session, guys. Okay.
Sure, sir.
Okay, yeah. So okay, so before starting with directly with the question, firstly I will try to give you some, from my experience, carbon materials and manufacturing. Okay, so carbon, you all know that what is carbon in periodic table, since our basic science, I mean class 6 or 7, we all know that carbon, but we never thought about that, okay, carbon will be that this much useful in our in a kind of in variety of the applications. I mean, it is the most useful materials in each and every sector nowadays. Not each and every, at least, but you can say in most of the sectors, carbon is replacing most of the materials. Okay, so this since it has a very unique property as compared to the other materials or the other elements, and that's why it has it came into the picture. So that we can use this material for the variety of your applications. So in this course we will be mainly covering about the carbon materials. I mean, what the carbon that doesn't mean only the carbon, that means also there are different kinds of the graphene, or the carbon nanotubes. So there are several types or forms of the material which are associated with the carbon, and how it will be manufactured, and how we can what are the applications, and how can we use, if we know thoroughly about this kind of materials, then we can involve, or we can learn about the basics of before research, because for the research we have to know some fundamental knowledge about this kind of a field. Okay, so mainly in this course we'll be covering week by week, and we'll see that what are the content are there. So in week one, the very basics, from very basics we'll be starting about the carbon, and how carbon evolves, and where we find, and some related questions related to our carbon materials. So okay, so firstly I'll be starting with this question. So nanocrystalline materials. Okay, so this is asking, are what are always in powder form. So okay, so in most of the research, or in your uh, basic fundamental books, you have heard this word nanocrystalline. Okay, so what is nanocrystalline? So if you know the nanocrystallines, nano is very, vast. If I ask, somebody will say that I'm doing my research in the nano field. Okay, so somebody will say I'm doing some 2D material, nano 2D material, or likewise. So here nanocrystalline materials are always in powdered form, cannot be used for manufacturing purpose, are always distributed in an amorphous matrix, can be a powder or suspension in a solvent. So this is very basic question. If you have any idea, if you have seen in your lab or something somewhere experience, then you can answer this question easily. So can you guys guess with that what could be the answer of this question?
Yes, sir. Nanocrystalline materials can be a powder or a
Hmm.
suspension in a solvent.
Hmm. Okay. What about others?
Yes, sir. This can be powder or suspension because nano fluid. I I have read about it.
Hmm. Okay. Yeah. Yeah. That's true. So that's basically means powder. Okay, so when we go for our research, have you heard about this, this nano, what to say this, some nanocrystal, or there are a very small particles when we go to see our compounds SEM image or the TEM image, then we see that our powder or whatever compound we have, it is in the nanometer range. Okay, and sometimes like a suspension in a solvent. Okay, so we can also make some suspension in solvents. That means, for an example, if you have seen any ink like for an example, silver ink, if you will say, so I will take some solvent, I will put my silver nanoparticle in that solvent, I can make some suspensions. Okay, so likewise in a solvent also we can see the nanocrystalline materials. So we can have a plenty of this kind of a suspensions, like gold nano ink, silver nano ink, platinum nano ink, lots of materials. So likewise we can also see it in the powder form, like silver nanoparticle, gold nanoparticle, there are so many. So these all will come in the powder. So yeah, that is true, it can be a powder or suspension in a solvent. So yeah, so here so in this lecture, what will be my pattern of teaching is that I will be mainly covering or taking the content from the NPTEL lecture of this course itself, and it will be helpful from where I have get this slide, so that you can also go and reread your slides, and from where I have taken this material, so that will be a useful for you guys also. Let me check my recording. Okay, fine. Okay, so in this lecture, I think it is a very first lectures. There you will be a slide of a micro. Okay. So yeah, there will be a slide of a microstructure of a material. So here, microstructure that describes the buildup of the material with a molecular resolution. Okay, so here you can see in a bold blue color nanocrystalline materials. So individual crystals are of nanoscales dimensions. Okay, like I have said, if you will see in a any imaging analysis or in any imaging instrument like SCM or TM. So basically nanoscales, what does that means? Nanoscales. So here you can see, suppose a 10 micrometer, here it is a 5 nanometer. You can't say this in nanometer scales, although you can transform it in the nanometer range, but here the nano means range is less than 100 nanometer. Okay, so that is your nanoscale dimension. They may just be available as a powder or may be distributed in a liquid, like as I said, some ink form or some paste form, where you have to take some solvents and you have to mix your nano powder or mixed with a binder. Sometimes we mix it with a binder. It means what? So when you make some kind of a suspension or any paste, then you have to have some binder, right? So that you can change the surface tension on the or the surface property or some other property like fluidity of your paste or your suspension. Okay, if they are conductors at large scale, they will only conduct when percolated, connected to each other. Okay, so what it is saying, if they are conductors. Okay, so for an example, I will give you a very basic example. If they are conductors means what? If I will take a suspension or as a ink you can say, or the solution you can say, or suspension, let's say suspension of your silver nanoparticles. Okay, so silver is what? Conductors. But in the usually in the suspensions we make binder. So binder is usually what? Polymers we take. Okay, so due to the presence of the polymer, the conductivity of your ink or your suspension will decrease. Okay, but by some processing or by some this what to say, there are several methods where you can remove the binders like heating, or there are many other methods. So at large scale they will only conduct when percolated. So the conductors, it means your nanoparticles should be connected to each others. Okay, so by removing the binder you can connect the nanoparticles or your nanopowder so that the conductivity can improve. So this is this line or this paragraph is saying all about this what I explained just now. So nanocrystals can be considered both crystalline and amorphous in the form of a bulk powder. Nanocrystallines, that doesn't mean that it will always be a crystalline. It can be amorphous in the form of a bulk powder. So here you can see nanocrystal powders here. These are some rod shape of a structure. So when you will magnify this, here you can see the structure, so in the SEM, and here you can see the scale. So yeah, so the answer is your can be a powder or suspension in a solvent. So I hope this is clear to you guys, or should I explain it more, or am I going okay?
Sir, one thing, sir, I would like to know
Okay,
about,
sure.
sir, percolated.
Yeah.
So what does the mean by percolated?
Okay. So you are asking me like what this word is saying. So here percolated, it means what? How should I? Large, they will only conduct when percolated. Percolated, that's mean this connected. Okay, connected to each other. So suppose for an example, if you have a many nanoparticles or a many nanopowders, so how they will conduct? Suppose you have a two metals. Okay, so two metals
Yes,
you
sir.
have to join somewhere, then only if you will give electricity, or you if you will pass the current, then only it will go to the other metals also. So likewise it should be connected, then only conduction will happen. Okay, so this is saying
Okay, sir.
large scale only conduct when percolated. Percolated, that doesn't this is not saying anything. That only means it should be here what is it? Nano crystal or the nano powder. It should be connected, right? Then only
Okay, sir.
any conduction will happen, whether it is a thermal conduction or whether it is a electrical conduction. So that's mean by this. So here, okay, is it okay?
Okay, sir. Yes, sir.
Okay,
Yes, sir.
fine. So, okay, so let's go move on to the second question. So, second question is asking about the carbon has many different allotropes because of carbon's ability to bond with itself to form chains and sheets, abundance of carbon inside the earth crust, high reactivity of carbon, manufacturing of carbon. So there are four things are given, and these are asking that carbon has many allotropes. First of all, do you know allotropes? What is allotropes? And if
Yes.
okay, what is allotropes?
Allotropes basically they consist of the same element, but
Hmm.
physically the physical properties or characteristic properties of the materials differ.
Okay, yeah. Hmm. That is true, right? So what she says that is right. So so can you guess what could be the answer? Why there are many different allotropes?
Carbon's ability to bond with itself to form chains and seeds.
Okay. Okay, so you know, I mean, you have seen many organic this kind of things. Okay, so yeah, most of you can also think like abundance of a carb because we there are many allotropes that why can't we can get from the earth crust and high reactivity of carbon. I don't think so that it is a very highly reactive. There are some allotropes which are reactive. Manufacturing of carbon, no, that is not. Okay, so yeah, the true answer is carbon's ability to bond with itself to form chains and sheets. So in a organic or in your chemistry, you have seen the many carbon can make a bond with itself, carbon carbon bond, and I mean so it can make a very long chain. Okay, so by changing this kind of a change or the sheets, you can find a many allotropes. Okay, so okay, so let me see here. Yeah. So here in point in this slide in the lecture 1, 2, 3, 4, 5. In the fifth point, you can see carbon has the ability to bond with itself to form long chains and sheets, which result in many allotropes. Okay. So here what it is saying about that the when the carbon chains will bond with itself. Okay, you can find depending on the how big chain it is and how it is arranging. So for an example, if have you guys heard about the graphite?
Yes, sir.
Okay, so graphite. Okay, so when you break the sheet, okay, so it is a stacking of what? If you break only one sheet, or so what it will convert? It will convert to the graphene. Okay, but if there will be the I have some, I will show you in the next class or let me just quickly stop sharing. Okay, I will be just showing you that how this sheet will look like. I had this kind of a drawing I have made for myself. So yeah, so okay, yeah, I got it. Okay, so let me again share my screen. Huh.
Hello, sir.
Yeah, hello.
Uh, is there possible to make graphene composite?
Yeah, why not? Many research are ongoing composite. So firstly, what you are thinking, I mean graphene composite, that's mean I mean what kind of a composite you want for what application. Composite you can make many composite it what you have some composite is nothing but a mixture of a two three materials, so you have to have some knowledge or pre background about that what you want to make and for what purpose, what property you want and what application you are targeting. So what you want?
I want just a like graphene is a single crystal and it has a very very high mechanical properties like uh, tensile properties, etc.,
Hmm.
etc. So
Hmm.
I
Sir,
think
sir, one thing I would like to add, using graphite
Hmm.
in manufacturing to make a composite material because of light in weight, just like make a aeroplane in a fuselage component of
Hmm. Hmm. Hmm.
aeroplane.
Hmm.
That's why, sir, graphene is basically very useful because of light in weight and good
Hmm.
thermal conductivity of a material. And also, sir, I have done some my MTech work about graphene
Hmm.
to make a composite material and then doing a milling operation and then applying optimization technique.
Okay.
and,
Okay.
and sir, I think about the graphene. Uh, it can be rehealing materials.
Hmm. Okay. Yeah. True.
So, like use of bulletproof jackets. So,
Okay. So
in,
you are saying
in,
that because of its
in defense
good
sector,
mechanical property, you can use this for,
yes,
for this kind of application for protection.
yes, sir.
Okay.
Actually, this is lightweight
Hmm.
and
Yeah, there are
easy,
many.
easy
In
mechanical.
fact, there are many. If you will see, that's a very good point that you both have brought here. So many researches are going in different fields, and many developments are also happening. So yeah, definitely there are many this kinds of graphene sheets and your some clothing material which is contains graphene and all. So these all kind of a lots of materials are available nowadays. So yeah, if you guys will get some opportunity, then definitely you can go and think and do some research in this, and hopefully you will get something very good. So yeah, what I was
Yes, sure,
thinking
sir.
to show you this image is when I got this sheet. So this is a graphene. Okay, so if you will make a stacking, if you will this I was saying that somebody now wants to join. Please be on time. So yeah, so what I was explaining here, as you can see, this is a graphene sheet. Okay, and what I am showing. So sheets, that's mean, so it is a single sheet. So graphene is 2D material. So if you will arrange this in a space or in a 3D, then it will make or it will become a graphite, right? So here in this slides I was explaining the same allotropes. So uh, carbon has the ability to bond with itself to form long chains and sheets, which results its many allotropes. So if you will change its structure, its molecular arrangements, or how these patterns and the chains are arranging, or the sheets, you can make any changes, then you can find a many allotropes. Okay, so because of this property, what is that property? Is that bond with itself to make a long chain and the sheets. So that's why it has a many allotropes. So the answer for that question is carbon's ability to bond with itself to form a chains and sheets. Yeah. So now, do you guys have any thing to say about this, or should I go ahead?
Sir, please go ahead.
Okay. Okay. So let's move to the third question. A carbonaceous material is what? Okay. So a carbon rich organic material, carbon allotrope, mixture of carbon and oxygen, carbon material found in the outer space. So this we all have heard this term carbonaceous. So it is very simple. So can you guys
No,
guess?
sir.
Huh?
Uh,
So a
I don't know
carbon,
carbonaceous material.
Somebody is saying something.
a
I don't know
carbon.
that term.
Okay. So
Yes,
what?
you may continue, Alexandra.
What? Carbon?
My
Which?
answer was a carbon-rich organic material.
Okay. Fine. And one is saying that it doesn't know, right? What about the other?
Sir, the carbon-rich organic material.
Okay, carbon rich organic. Yeah, so this is true. Carbonaceous is a very simple term. So, carbon rich organic material. So, this is very simple. Carbon allotrope. I just explained that carbonation, that doesn't mean a carbon allotrope. I explained you what is allotrope, and mixture of carbon and oxygen. So this is not like this is not true. And carbon material found in outer space. No. So carbonation. So I will explain by this slide. So carbonaceous material is what? So again, you can find this in this slide that okay. Yeah. So in bullet 4, you can see the formation condition of a carbon allotrope or carbonaceous material can provide details about geological phenomena. Okay. So the materials which are rich in a, organic material. So what happened usually, for a human body, let's say any kind of organic materials. Okay. So after dead, or you can simply think before many decades or centuries, there are many living species who, due to some geological phenomena, they went inside the earth crust, and they become uh, because of its organic materials. So now we are getting a different kinds of carbon in a different forms. Okay. So uh, so because of this organic materials, they are rich in carbon. Okay. So these all materials which are due to its geological phenomena, what we are getting, they are rich in a organic. Okay. So this kind of materials is nothing but a carbonaceous material. There is nothing. So yeah. So carbon rich organic material is called carbonaceous material. So let's move to the fourth question. It is very simple. Manufacturing process used for polymers can also be used to manufacture carbon-based structure. So because of what? Property of polymer and carbon are similar. So in polymer also, what you will see is a carbon only, right?
Yes, the backbone of polymers are carbon.
Okay. So others who joined late, please join. Be on time. It's 7:40 around. Okay. So yeah, somebody was saying something.
Polymers generally have a carbon backbone, but
Okay.
there can be inorganic also.
Okay, okay. So yeah, that is true. Usually the polymers also, they contains this carbon chains are there, and there are many attachments like hydrogen and oxygens, and there are many things you can find. So basically this is asking manufacturing process used for polymers can also be used for carbon based structure. Okay. So why we can manufacture a carbon based materials also? Because of this property, or the polymer can be converted into carbon. Polymers can used in carbon based composite. Polymers have carbonaceous backbone. So it is very
So
simple and
poly
clear. What?
such polymer are used in carbon-based composite.
Polymers are used in carbon based composite. That is okay. I mean, but it is asking about manufacture. I mean, how can be the manufacturing process that we are using for polymer can also be we can use, or could be the same for the carbon based structure. Think what could be. What you are saying, polymers are used in carbon based composite.
Yes, sir.
So actually that is not very true. I mean, the main reason is the properties of polymers and carbons are similar. Okay.
Okay, sir.
Huh. So
Oh,
that's why, I mean, because carbon is what? Carbon is carbon, but the polymers also, that contains a carbon chain. So somewhere the properties are related. So when we manufacture any kind of a polymers, we can use some similar kind of a method to manufacture carbon based structure, right? So when you will go ahead in the lecture series, you will find a many manufacturing process how we can manufacture this carbon based structure. Likewise, I said you some graphene or graphite, there are some more forms like carbon black, carbon nanotube. So how can we develop, or how can we synthesis or manufacture a carbon based structure? So there are something similar, so which is nothing but the property. Because of it's there's quite similar property, we can use the same, right? So this is the polymers. Okay, just a second. Polymers. Okay, I was sorry, I was wrong. Properties of the polymers are true, but not very exactly, because in the polymers there are chains like polymers. There are for an example, if we will take a cellulose, so cellulose, there will be carbon chains, but there will be a functional group also attached, like hydrogen or hydroxyl or some other groups. Okay, so properties are not very sense, it depends on the functional groups added. So the right answer here is the polymers can be converted into carbon. So can you think how it can be converted into the carbon? Polymers, it contains carbon, that is for sure. That's why I also got confused because of the properties, because mainly it is a carbon chain.
By breaking the by removing the functional groups.
Okay, that is one type. True, that is true. Okay, so for an example, suppose you have some polymers. Okay, definitely it will have some carbon and it will have some other groups. So if you can decompose by any means. Okay, suppose your material is having some binder or something. So for an example, if you can do some annealing, or you can do something, some sort of any experiment through which you can remove the other. Okay, then you can get a carbon, right? So that's why the polymers can be converted into carbon by any method. So this in the lecture series we will see that how it can be converted further. So okay, so it is related to your crystal structure. So if you know a little bit basics about the crystal structure, so if you know like what is single crystal, what is amorphous, what is polycrystalline, so it is asking like a definition. It is, you can say, materials having crystal oriented in different directions is what it is saying. Different direction. This is the key point. Different directions. From here you can guess.
Polycrystalline.
Yeah.
Yes,
That is
polycrystalline.
true. Obviously, it is a polycrystalline. So single crystal, it means what? The orientation will be only in one direction. Okay. Amorphous will be what? I mean, amorphous. I mean, there will be no any crystalline sort of directions and all. Okay. Polycrystallines. That's mean your crystal planes will be oriented in a different directions. So that's why it is called a polycrystalline. So the materials which have a crystal oriented in different directions are called polycrystalline. Fine. Okay.
Yes.
Yes, sir.
Okay. Okay. Yeah. So deep carbon. If you have seen the lecture, or if you have noticed, or if you have heard somewhere somebody is using deep carbon. So what does that mean? Deep carbon is deep research in the field of carbon allotropes, diamond that is only present below 2 kilometer of the Earth's surface, graphite that is only present below 2 kilometer of the Earth's surface, or a collective study of various carbon material found below the Earth's surface.
So the collective study of various carbon materials found below the Earth's surface.
Okay, okay, yeah, right. So, okay, so I will ask you one question. Okay, so that is true. Deep carbon is this, that here we will study about various kind of carbon. So, do you have any idea? I mean, what kind of materials we can get if you have seen the lectures, or any basic knowledge from the Earth's surface? What kind of a carbon? material we can get, or you are using in your
Oh,
day-to-day life? Yeah, any please
Uh,
speak. It's just an
I think
introduction.
I think petroleum and graphite also.
Okay, petroleum, yeah, that is true. What about others? What else can we get that you are using? Very
Coal.
basics. Coal.
Mhm.
Yeah, that is true. Exactly. Coal we are getting in a very enough quantity. Basically, we get coals. Yeah. What else? We can get coals, graphite, and we can get some petroleum material, and also, diamond. Sometimes we get diamond also from our earth crust, right?
yes, sir.
Okay.
So the organic compounds are
Okay, so do you know that from where these all are coming? I mean, how can you just you're digging the earth and getting so much of this kind of a material? So what happened way before or a century before that we are getting this kind of a things?
Formation of fossils due to change in climate and collection of organic matter.
Okay, yeah, that is true. Okay, yeah. So a years ago, maybe a century or many thousand years ago, some this geological changes or the climate changes. So due to which some organic or this for they all after some time this they all converted into this because they all the materials are organic, so that's why there are the different pressures and temperatures also. So different regions, and there are many parameters which will give you in a different place a different kind of a material. So yeah, deep here the question was about the deep carbon. So it is nothing but a study of a carbon material that we found below our earth surface. So here in this slides, again this slides contains many you can say a basic knowledge about your this material. So here you can see in third point, deep carbon is studied for understanding the evolution of earth. So organic compound decompose. Okay, so very thousands of years ago there are many organic compounds that went inside our your earth and that decompose. Okay, so they all decompose to yield carbons, hence we have various carbon forms below our earth crust. So this is known as a deep carbon. Okay, collectively it is known as the deep carbon. So we are a carbon based life form. Entire organic chemistry is based on carbon only. You will only see the carbon, right? So the formation conditions of a carbon allotrope carbonaceous material can provide details about the geological phenomena. That what had happened that time, what geological phenomena. So what kind of a allotrope you are getting, right? Formation conditions of a allotrope, like what were the pressures and the other parameters, and what kind of a material, carbonaceous material you are getting. So that will provide you the details about your geological phenomena. Okay. So, a collective study of various carbon materials found below the Earth's surface. Okay. So, the next question is microstructure is defined as what? So, I think if you know the some metallurgy, if you have know the microstructure, then you can say something or comment on this. Or it is a very basics also you can say.
first one, sir. The
Okay.
dual stress phases and the defects.
Okay. So why first? Why you are saying this?
So because of buildup of material with a molecular structures.
Okay. Mm-hmm. So what, why, if there will be a build-up, then what, I mean, microstructure, then why it is necessarily to define why these three things are combined? I mean, why?
So, because in a very small means micro
Mm-hmm.
extremely small regions, because of micro is associated with one micros.
Mm-hmm. Okay. Okay. What about others? Any else? Any other points to
Um,
come?
Microstructure basically shows whether the
At a
material
small level, sir.
Hmm. Yeah, yeah. Somebody is saying something.
shows that the material's crystallinity or how amorphous it is. So residual stress, depending on the crystalline structure, phases if there are more than one phase in the material, and defects come are inherently present in any material. So that is why microstructure would be defined as the first one: residual stress plus phase plus defect.
Yeah. Yeah. Right. Okay. True. So yeah, you both are right. Anything else you want to add on this?
Sir, I have one question. If
Hmm.
we go to nanomaterials,
Hmm.
uh, what, like, nano dimensions are much, almost 1000 times less than a micrometer.
Okay.
So this definition of a nano, would this definition be applicable to a nano structure?
I mean, what, for what dimension you are saying?
In nano dimensions, we
Uh,
see that basically any nanoparticle or nanomaterial is
hmm.
defined as something which has at least one dimension from 1 to 100 nanometers.
Right, right.
So, a what would be the definition of a nanostructure as such?
Nanostructure. Okay. So if you will ask about the nanostructure definition, then definitely nano, it means that it should be less than 100 nanometer technically. But here, if you will go, you can say also, if you have something, let's say 1 micrometer, okay, you can also say 1,000 nanometer. You can convert, right? But if you will see, it will not come under the nanostructure. How can it will be a, a nanostructure? It won't be a nanostructure. For the nanostructure, it should be less than that 100 nanometer range, right? But yeah, you can convert that, and you can also say to the nanometer structure range, or you can, likewise. But for a bigger structure, or for the bigger picture also, you can convert, and you can say in a nanometer dimension range. But if you will specifically ask about the nanostructure definition, then definitely it should be in that range, so that you can, justify your statement. So okay, I have this nanostructure. Let's say I have a carbon nanostructure. So if you will, so after giving this statement, okay, I have a carbon nanostructure, and you are showing something in your images that is in a micron or a range, or a thousands or the hundreds of micron, then that doesn't make any sense about your nanostructure, right?
Yes, sir, it's clear.
Yeah.
But with respect to that only,
Hmm.
like when we say defects are inherently present,
Hmm.
so nanostructure as such, there would be no, like, this would not fit for that. Only that 100 nanometers it is less, right?
Yeah, for nanostructure that is different, and if you will bring the defects into the picture, that will be altogether a different scenario. Okay, so defects, that's mean a something else. I mean defects, how to say your suppose let's say a metal. Okay, if you will have some metal, so in metal, there are many phases, there are grain boundaries, there are so these all are grain boundaries, also kind of a defects. There could be some inclusions, there are some other particles. Okay, so during the manufacturing process or during your processing, there could be some defects can be present. But
Excuse
if
me, sir.
uh,
Uh, why amorphous regions are not?
why amorphous regions are not okay, so here it is like a, let's say you have any material, okay, so in material what you will have basically, if there will be a phase, then how you will get amorphous regions also. Suppose do you know urban, do you know the about the phase, what is phase?
Yes, sir.
What is phase?
Uh, actually, two different type of arrangement.
Hmm. So I mean, okay, fine. Phase, okay, let's say according to something is there na. So if there will be a phase, let's say in a carbon iron carbon diagram, do you know this if you are from metallurgy, then you must be knowing this, right?
Yes, sir.
So if there will be a phase, then how can, then that will be in some order, or that will arrange. Definitely there will be a defects, but that will be having some arrangement, right? So amorphous reasons is what? There won't be any kind of a arrangement, and that will be a not crystalline. Amorphous is altogether different thing.
Uh,
Okay,
I
so
got, I got, I
if you
got.
will have, if you will incorporate the phase, then there will be a defects. Defects is what? That could be come from like as somebody said, from inherent, or during the manufacturing, during the processing, or later on process also you can have some defects. Residual stress is something that is definitely you can also have I mean, if you will there is a altogether different that I will discuss in the later slides. So yeah, so the main thing is microstructure describes here in the slides, as I shown you before, build up the material with a molecular resolution. Okay, so if you will see any pictures in a more magnified version, then there will be a phase, defects and stresses. Okay, so if you will change the stress, so the microstructure can change, if you will change the stress, if you will change the phases, then the microstructure of your material, because this all will contribute to the property of your materials. Okay, if you will have a different phase, then or the stress will change, then the altogether property of your material will change, right? The term micro is used for everything that is extremely small. It is confusing because micro is also associated with the unit. So micrometer, that's been 10 is to power minus 6 meter. Micro scale structures used in device are also sometimes called microstructures. That is very basics. So after that the nanocrystals came, which I already explained. So nano means 10 is to power minus 9 meter, right? So yeah, in the microstructure, this all, if you will change anything, then altogether your microstructure will get affected. Is it clear to you guys?
Sir, in amorphous regions, sir,
Hmm.
there is a possibility of a disordered state of flaky form of material.
Okay. Okay.
So,
Hmm.
what the impact, basic impact about if we try to in microstructure?
Hmm. Then what will happen? You just give any example how you will incorporate, then what you want. Let's say an example if you want to give. I mean, how you are incorporating the amorphous things in the microstructure. Anything or any you have seen in your experiment life or any research.
I don't know about
So I
this
mean,
thing.
just don't make it very complicated. This is not that. If you will find if you will see about just in this lecture, or if you will see any take a very basics book of your introduction to material science by the Callister, of a very basic level book of a, you can find it is what is microstructure, what is phase, and what is your this crystal structure, how many times. So these are there. Okay, so don't make it very complicated by just keeping some other randomly hypothetical things. So this is very basic. Okay,
Okay, sir.
so yeah, so let's move to the, yeah, so in the lecture, if you have seen this lecture, the Taylor expansion of material properties is around the field function f. What does f equals to 0 mean? So if f equal to the 0, then what will be? Only 0 ordered term indicating permanent material property, linear range of material property value is just at the beginning of the experiment, property value just at the end of the experiment. So firstly, do you know the Taylor expansion? Or if you have seen the lectures, maybe you,
Yes, I think the answer is the property values at beginning of the experiment.
okay, how can you get this if you will f equals to 0? Do you have some idea, or if you remember? We will all, I will discuss this, but just for the discussion. Or what about others?
Don't know, sir.
Okay.
Sorry, actually my internet connection was disconnected.
Okay, okay, fine, fine.
So
No
the
problem.
response of a material is as a function of the field, and whenever we have any function, we
Hmm.
have r is equal to then r naught. R naught is said to be the value at inherent property of that. But when f at f is equal to 0, so we feel see the property at when there is no field applied. So
Yeah,
that
that is very, yeah, yeah, absolutely right.
mm,
So, in this slide, have you seen this lecture? What about others?
Yes, sir.
Okay. So here, this response is a function of your field. Okay. So it is given by the Taylor expansion. So let's say f of x equals to, so if you will write in terms of f0, summation of from n equals to 1 to infinity, 1 upon factorial n, and here it is a differential d is to df dx to the power n, and x equals to 0, x to, and again xn. So here it is your Taylor expansion, and here if you will put r, so it f0, it will be a beginning, okay, r naught. So here again, if you will define from x equals to 1, here it will, you will say the field f equals to 0. So here you are putting the value and 1. Okay, so here it will come your dr upon df, here f. Okay, again here if you will put the n equals to 2, then again and likewise. So here it is saying if your field is 0, so f is your 0, then what you will get only r naught, right? So if you will get what is r naught, this properties value just at the beginning of the experiment. Clear? Clear, guys? Or have some doubt?
No, sir.
Huh?
Clear, sir.
Okay, yeah. So property value just at the beginning of your experiment. Okay, so it is a application based material. Okay, so before this, uh, have you know this? Somebody was saying few minutes ago that some composite or carbon-based composite or something like that. So do you or somebody was saying some good applications like some due to its mechanical property. So what kind of a more applications have you heard about if I will say a carbon-based composite or the carbon-based material? Do you know uh, any applications or have you seen in your life or in the research field?
As electrode materials,
Yeah, that is true. So as a electrode material, what? How can you use for what purpose you will use that electrode?
electrode as for maybe say a supercapacitor, we use carbon materials, carbon-based materials.
Okay, okay. So that is one.
As a superconductor.
Superconductor.
Oh,
Where
sorry,
have
sir.
you seen superconductor?
No, no, sir, no, sir. High conductor, मतलब high conductivity, very high
Okay,
conductivity,
very high conductivity. What does that mean? High conduct electrical conductivity, thermal
uh,
conductivity.
electrical conductivity.
Okay. So which material you know that carbon-based material that you know are very high conductive?
Graphene.
Okay. So where can you use that if I suppose let's say I will give you a metal is also very high conductive material. If let's say I will give you aluminum, I will give you graphene. So how I can say that I can also have a lots of high conductive materials, but how where will I use that? I can have so many things which will have a very good conductivity. So where can you use? Think about some applications so that you can, you know, yeah, you are right.
Don't
Conductivity.
know, sir.
No, just think it's just to discuss. I mean, you can think and you can suggest. It's not something that you have to know.
In nanochips,
Nanochips. Right now, I have not seen using in nanochips using carbon kind of a material. Could be possible, but I also don't know. I'm just asking about the applications that what you can think. I mean, carbon is nowadays you can have a lots of application. Carbon is doing fantastically amazing job in research field. Wherever you go, wherever in institute, mostly people you will find working in carbon type of material, carbon fiber composite, graphene material, graphite material, reduced graphene oxide, carbon nanotube, or what else are there? So many things. You can think and say about that the slides which I'm showing. You guys are not, I think, not seeing the slides. You can pick it some which is true, and you can say something from there.
aircraft body parts.
That is right. So okay. So let's say if I will use a aircraft
Electronic insulator is
electronic insulator, why you will use as a electronic insulator? If somebody said that they can use carbon as a highly conductive material and you are using that for the insulator, could be possible. You have to that's all depend on the manufacturing process. So where you can
yes,
use
sir.
as a insulator.
Of course, sir. Thermo thermosetting materials are uh, electronic insulators.
Thermosetting material, now you
Sorry,
went very
thermosetting polymers materials, sir.
uh, Okay, so there that is a polymer. I'm asking about the carbon-based material. That is altogether polymer is different and the carbon is different. I'm not asking about the use of your any kind of a polymer. Otherwise, you can use in a many things. Yeah. So somebody was saying
In foundry,
aircraft body.
hello.
Huh?
In foundry preparation of ladle, we can use that carbon in the refractive material.
In foundry, we can use
In foundry, the ladle preparation,
ladder preparation. Okay.
yeah, the lining we use the carbon material with the graphite to withstand the high temperature of the
Okay.
material. Yeah.
Okay. Yeah. That is also interesting. Even I also don't know. See, that's why I'm always open for the discussion because I'm
Yeah,
also learning from.
generally the high temperature in the metal will be forms to
Okay.
withstand that high temperature. They will use the graphite and carbon as a as a what we say that as a bonding like that as a layer. It will be withstand that one,
Okay. Fine.
and the temperature also will be withstand. For example, for grain we use 1200 degrees centigrade. It should be during that first ladle, first pouring to last pouring. It should be withstand the same temperature. Otherwise,
Okay.
there will be a lot of material defect in that pouring of the
Right.
material.
Right.
Yeah.
Right. So because of its with temperature withstand property, we can use this in a foundry. You are saying.
Yes.
Okay. Fine.
For
Okay.
preparation of the ladles. Yeah.
Okay. Ladle. Okay. Yeah. So it seems that you're from metallurgy background, right? Hello.
Yes, sir. Yeah.
Okay. So, who was saying? So are you I mean, a student or
I'm working and I'm doing MTech metallurgy
where?
in Tech University. I
In?
have in Tech University in Chennai. Yeah.
Okay. You're doing MTech in metallurgy.
Yeah, metallurgy, and I'm working in MNC. Yeah.
Okay. That's very
20,
nice.
yeah, 27 years on field. Yeah.
Okay, yeah, nice. Okay, yeah. So that's good point. What about others? Can you bring or say something? Then I can say some my experience also because okay, let's say I will give you a very some field. Let's say electronic field. Can you think and come up with something that can be used for the electronic? The electronic property already you know about. Somebody said the conductivity. So how can I use this carbon as a in the any device or any kind of thing? Just think.
Preparation of carbon electrically conductive inks for I've heard of this that conducting ink and
Very
like
nice.
printing.
You are going in a very right direction. In conductive carbon is very right. So how can you now the question is from what application for what application we can use this kind of a ink? Just your one steps before. So yeah, conductive carbonics is very right. So I mean, how on what application can use that?
To basically manufacture or to prepare nano circuitry.
Okay. So basically, okay. So let's say, do you guys heard about any heater? You know heater, right? You know heater, right? You have seen in your home the coil heater where we use our
Yes,
some metallic, and when we give our voltage that will start burning, and there you can boil your water, you can cook any, right? Huh?
Yes.
So similarly, let's say if I will give you a carbon ink and you can make something, and because your carbon is conductive, I will apply voltage, so you know the conduction property, right? How the metal will heat when the current will pass, metal will start at heat now. So similarly it will also start heating when we apply a voltage. So can we use this for the heater? What do you think? I know this is very new because this is something that which I am also sharing, and this is a cutting edge research that is going, it's very interesting field. So does this sound interesting that carbon can be used as a heater or not? Or not a good idea, you are saying?
Yes, it's quite interesting. Something
Yeah. So
different to know.
exactly, it is very different. So here you don't need to make anything. You know about the flexible, you can take any flexible substrate, you can take any, and you can just put your carbon material, you can just print your carbon material on top of your flexible substrate, and you can apply a voltage and it will start heating, and that can, depends on the conductivity, can give you very good amount of a heat. So these are some kind of a field which I am talking about. Okay, so when you will, just a search in a Google or somewhere, you will find a many variety of things. Just nowadays this chat GPT also came, you can just see and play with that, right? So, okay, so let's come again into the question, because sometimes I'm very interesting. Sorry, sometimes I'm very interested to discuss about the applications, because we never know that what you people are thinking, what from where. Because in the research field, everybody is doing somewhere a similar kind of a research, but the main thing is don't involve in this, research which is going from a very past. Again, you are doing something, the next person will come and again change something, and they will again doing the same thing. So the main purpose of this research is to make something useful for your society. So for the society you have to have some good applications. I may not give a good applications, but if you will really see the problem, or if you will find something from where we can use our mind, our research interest focusedly, then how can we come up with something good idea? So that's the main point here, right? So okay, here they are giving some very basics, or the how the word are using the carbon fiber based composite. So basically I will give you firstly the answer. First is the bone implant, second is somebody said the aircraft body parts, which is right. So after that I will give you how can we use this. Thermal insulation coating, not carbon is not insulation coating. Firstly, I'm saying you, because it's conductive. Okay, so composite materials are prepared by, so composite, that's me mixing two or more chemically and physically distinct material in the form of a matrix or additive. Okay, so let's say if I will take any my carbon material, if I will take any binder, or I can take any polymer. Somebody was saying something, can we make a carbon composite? So yeah, here I'm giving your answer. So if suppose if I'm taking any carbon, okay, so that should be a chemically and physically distinct material, right? Then only you can make composite. But also, I think somebody is joining very late. So from the next class, please be on time. Okay, so composite materials, that is like a more, I mean, mixing two or more chemically and physically distinct material. So when you combine two material and mix them properly, homogeneously, you can make a composite. So for composite making also there are plenty of methods. How, what is your purpose, what are the applications you're focusing, and how you want to make like layer by layer or some matrix kind of a thing. So carbon structures such as carbon fiber, carbon nanotubes are mixed into polymer matrix directly or as laminated layer by layer. So it is saying, so suppose let's say you will take a carbon fiber or a carbon nanotube, and definitely polymer. So polymer you can use here as a binder, so that it can make very good what should say mixing property. It will create a very homogeneous property, will get a homogeneously. right? So polymer is used as a binder material. So here you can mix it directly, or you can just put a layer by layer. For an example, you can have some carbon structure, and then on top of this, here you can say in the laminated composite, this is a carbon structure, then your binder, then carbon, then binder, then carbon. And you can make a this kind of also composite, so that doesn't affect much, but it also depends on the property or the application that you want to use. So surprised that why people are joining after this late. So again, I will request you guys. So like, if you are really interested to attend this doubt clearing sessions, then please be on time from the next time. So that will also not create hindrance when I will explaining. So, and also for others. Okay, so composites feature a high mechanical strength. So as I mentioned, in the aircraft body, what is required, if suppose if you are using anything in the aircraft or in a aircraft body, then it should have some good mechanical strength, right? So that's why where also you can make a composite. That's mean what, suppose if you have some one material that cannot fulfill the property you want to, then you have to go for the other materials. When you will combine two or more materials, then you will get a desired property. So let's say a mechanical strength, whatever the mechanical strength you want, you can't get by a single material, then you have to make a composite, right? So here that will come into the picture. So that's why we can use this in a aircraft body parts.
Excuse me, sir.
Yeah.
Uh, Sir, actually, I have two problems in both assignment, week first and week second.
Okay.
Can we discuss?
What kind of a problem?
Assignment in assignment two, question number first.
Actually, I have not seen your assignment, frankly speaking, because I'm just taking the questions, and I'm hoping that it will be quite similar. That's what I'm discussing, but I do not know the questions exactly.
Uh,
So I will try to, connect. I cannot, we are not allowed until and unless if you are not submitted your, assignments. I cannot clearly answer your questions, but yeah, I will give you a hint and I will try to, connect with the concept or the topic. So yeah, if I know, otherwise I will also have to see. Yeah. So yeah, please say.
One sec, sir. Uh, Calculate the reaction rate constant
Okay.
for uh, Buckminster Fullerene C60 to
Hmm.
diamond conversion at 300 Kelvin, 1 atm. Give the energies of formation C60 and diamonds are 2280 and 2.9 kilojoule per mole. Um, I want to share my solution.
So actually, this is from module 2, I think so, right?
Yes, sir.
So you guys also got the assignments for module 2.
Yes, sir.
So when is the deadline?
Uh, Tomorrow.
Tomorrow?
Yes, sir.
Okay. And what about the assignment 1 you have submitted?
Yes, sir. I have submitted, but one problem. There was one problem.
Okay, so actually I also because module I have not prepared the slide yet actually. So if you're asking about this reaction rate, then also I have to see some concepts because we are instructed to take classes from today, like this week, but I don't know. I mean, when is your deadline and all? So definitely, if you, I mean, try to solve from your side because I also have to see that from which concepts these questions came. So, and if not, then let it be there, and we'll discuss it in the next class, guys, for sure.
uh,
Okay.
because sir, I have done the question, but answer is very very different of type. Uh,
Okay, okay. So,
two,
okay, what I will
I am
suggest.
actually I am not getting answer.
Hmm.
Uh, I have 3 or 4 times that question attempt,
Okay.
and I get two solution more accurately, and both solution has uh, two unknown, two
Okay.
unknown and one equation.
So,
This,
others, what about others? Maybe that's why this is like interaction sessions, more or less. So, if others, can you help your colleague or your classmate? If you know, maybe he is facing something and I do not have seen the question and don't know the concepts yet. I think it's about the reaction rate, right? Or some activation rate you are asking. Hello? Hello?
I have done one solution in enthalpy change,
Okay.
uh, and another one activation energy.
Okay.
But both equation have two unknown and one equation
Okay.
in last.
So,
So
okay, that is fine. So what I will suggest you, because I do not have anything to say on that, so I will see your questions because I have not seen your assignment. So I will see, and I will also try to, prepare a solution for your question, and I'll discuss it in the next class because I have not, solved your questions right now. So will it be okay?
okay, sir.
Okay. So what I will suggest you guys also, if you want, you can, contact among yourselves, and if you know each other, and that will also probably help to understand better. So because sometimes it happens that maybe I may not answer all your questions, but your friends may. So that will be also one of the most useful. But yeah, because here this time I have not seen your module 2. I have neither seen your module 2 nor your assignments 2. So I have only, this week. Actually, this is a week by week our session. So the pattern of this program is like, firstly we have to, after your assignment 1, we will take your this session, so that whatever the problems you have faced in your assignment 1, so that we can clear it here, and after that, after your assignment number 2, we can or your we can discuss the lectures of your module 2. So whatever the questions you have faced,
Sir, am
that
I
we can
audible?
discuss that there. Somebody wanted to say something.
Yeah, I just want to discuss the answer for his question.
Okay.
This sum has been dealt in the class itself. It is the nothing but the conversion of diamond to graphite. The same thing is given here, and here we have to find the reaction rate constant, and they have given the values for C60 and diamond. We just want to substitute the two values, which is the energy. Um, I think so for C60 it is 2280, and for diamond it is 2.9. So we have to consider for the Gibbs free energy, we have to substitute. And then with the use of formula, which is K is equal to e power minus delta G reaction by RT. Just we have to substitute the values, and there is no use of the pressure here. They're just given. Other than that, if we substitute all the values, we are getting the answer directly.
Okay. So, what about others? Did you get that? What she said right now? Hello?
Not completely.
Not completely. So, okay. So, what I will say maybe next class. So, who was explaining that? Durga, right?
Yes, sir.
Okay. So, Durga, I will also come up in the next class. So, for your classmates, can you make any write notes or any PPT so that they can understand in the next class?
Yes, yes, sir.
Okay, okay. So, okay, so maybe she will help. So, yeah, this is also a wonderful thing that if you guys are come up and help each other, your friends, so we can make this session a more useful, right? So, because I'm also a learning and weekly, I'm also, for you to prepare these sessions, I have to see and I have to watch all the lectures and making all the contents, questions, PPT and all. I have to put so much effort. So yeah, definitely I will also try to see because I have not seen yet your assignment number 2 and a similar kind of a question. But yeah, I'll look for that. Okay, so I will request Durga to please share the some concepts in the next class so that the others can also understand, right?
Okay, sir. Okay, sir.
Okay, yeah, fine, fine. Okay, so yeah, can we go ahead or do you have any more problem or anything to say? No, so can we go ahead?
Yes, sir.
Okay, yeah. So where we were? Okay, so we were somewhere mechanical strength, right? So here the next point is a carbon polymer composite can also be converted into carbon carbon composites. Okay, such materials can withstand a high temperature. So high temperature, right? So here again, like somebody recently said about a very good example that we can use in a ladle. So yeah, that was very right because it can withstand a very high temperature. So that's why we can use where we need a very high temperature. So this is a very good example that somebody has given few minutes ago. And many applications of carbon fibers are actually via composite formation. That is true because in composite we can use a two or more materials and we can come up with a good applications. Examples in aerospace. So as I said, in the aerospace application, because of its good mechanical property, high withstand property, and there are many other property, we can use it in aerospace application. Biomedical implants, so this is also one of the most attractive field where you can use a carbon based materials. Okay, biomedical implants. So implants, that what does that mean? So implants means, suppose when your bone got fractured. Okay, so for an example, okay, let's say if I will use any metallic, suppose metallic implant, then can you tell me if you have heard or something disadvantage that can be overcome by using a carbon based composite? If I use suppose a titanium implant, then what issues can be faced by that we can resolve by using this carbon based composites? Can you comment something on this? Then I will tell
Co-
you guys.
corrosion of metal implants
Okay,
because but carbon is like human body is also made up of carbon material, so that is quite compatible.
right. Okay, what else? Something, some problem, some more problem you can face if you will use a metallic implant. Okay, so I will give you a very basic example. Suppose MRI, you all know MRI, magnetic resonance imaging. So do you know that? Have you seen any images of MRI?
Yes, sir.
Okay, so there what we usually do, we some magnetic field will apply. So due to that, the ED current will be there. So your metal will get heated, right? So if your metal will get heated, then it will kill your cells, which you don't want. So it should not, have that ED current. It should not heat. So from there, this is a very good thing that where you can, come and you can replace your carbon-based composite and you can make your biomedical implant. You can replace your metallic implant because it won't heat. It won't kill your cells. It won't make any hindrance inside your body. It won't heat up your body so much. And the metal is very highly thermal conductive. If the heat will, I mean, if the current will pass, right? So that's the thing. That's the main advantage. And also various structure materials components. So yeah, in the civil parts also you can say nowadays people are using this. CC composites and hybrids is a rapidly growing industry, which is true. Recycling of carbon material, including carbon fiber composite, is also challenging. So yeah, that is challenging in itself only. So yeah, these are the some materials. So the answer was the basically the main things is very simple, but why I'm emphasizing so much is that the application is okay, but how you will think about some application if you will know the basic fundamental, if you know the property, and how can you use that property to bring something or come up with some new application by using that novel or the unique property. So that's the main fundamental about, or the basics. If you know anything, if you know the basics, then only you can come up with something new or attractive. So yeah. So, okay, let's go to this. This is, I will, okay. So, right now I'm only discussing. So, I will also give you some, kind of a small homework. So, disordered carbons are sometimes called amorphous because what? So this I will ask you in the next class why this disorder carbons are sometimes called amorphous carbons because of its low Young modulus, electrically insulating, shatter into random pieces on breaking. Materials are generally classified only as amorphous and crystalline. So please come up with the answer and the reasoning also, not just an answer. So yeah. So, which of the following properties indicate a non-zero response in absence of an external field? So again, if you remember this Taylor series expansion from where you can give. So suppose non-zero response in the absence of external field. So have you seen that part? If
Yes.
field will be your zero, then
Can you please show the question number 10 for a minute?
okay,
Okay, sir.
okay. So can you give me answer for this?
Sir, ferromagnetism and radioactivity.
Okay, fine. What about others? Say something. Okay, yeah. So again, if I will go to that slide again, this one. So here, if you will put your, ferromagnetic, suppose, let's say your field, okay, so absence of the field, your this response will not be zero in case of a magnetic ferromagnetic. And similar, I do not know because I have not, I mean, I can't see about the radioactivity, but here, this I can say that. About your ferromagnetism. So it is asking following properties indicate a non-zero response. Non-zero means R naught should not be equal to zero in the absence of atom. So when the F equals to your zero, then in case of ferromagnetism, as
Non-linear region.
huh?
Non-linear.
Okay, yeah. Then what?
Sir, R0 is not equal to 0. That is means non-linear regions indicate.
Okay, okay. So yeah, so okay, so you are saying about that. Okay, I thought you were asking or some commenting about it. So yeah, so for ferromagnetism and radioactivity, you will get that. So okay, so isotope. It is asking about the isotope. So do you guys know about the isotopes? What is isotopes? What is isotope?
Which is a different form of same element with same number of electrons and different number of protons and neutrons.
Right, right, true. Okay. So here it is C13 isotope is used in NMR spectroscopy. So first of all, do you know that what is NMR and what for what purpose we used it?
Yes, NMR is the basic phenomena which is used in MRI scanning also. So basically, it is used to find out whether there is presence of some kind of material or amount
Yeah,
of that
you can
material.
say the element or the compound. So let's say if
Mm.
you have some compound, then what is there, right? So yeah, that is true. Spectro. So be clear wherever the term spectroscopy is coming, there we are finding something, okay, whether it is elemental or where we are finding something else. So its mean is finding, okay. So here also we are finding in NMR, we find some compositional analysis, okay. So what is present in your compound. So do you know that for NMR we use what, C13 or some else isotopes, or it is true?
C13, true sir.
Okay. So in the slides, you will see there are three isotopes they are showing. So somebody like she explained, which is true, similar number of electrons and the different number of neutrons and protons. So here they are sorry, similar number of these protons and the different number of your neutrons. So here you can say six protons. This is carbon 12 and 13, seven neutrons, six proton, and carbon 14 isotope, six proton and 8 neutrons. So these are some, so for 13, carbon 13, these are the isotopes where you can see. So here you can see in this point, 13 carbon is used in NMR spectroscopy. Why? Because it has a, so when you will hybridize, if you know the hybridization, it will come as being -1/2. So if you will see the lectures that why -1/2 is using, so there you can got there you will get to know that why it is using it NMR spectroscopy, right? So yeah, this is true. Unlike amorphous material that shatter on breaking, crystalline material break along a certain crystal plane. True or false? Hmm?
True sir.
True. Others?
True.
Okay. So yeah, which is true. So when you have you seen any kind of a crystalline material? So that there will be many crystal planes. So that will breaking will happen or the fracture will happen to the orientation or you know it's not any randomly breaking or the shattered kind of phenomena you will get. You will get the breaking will through the any crystalline plane in a crystalline material. So yeah, like as I discussed few minutes ago, or carbon-based bone implants produce artifacts during MRI. So just I have explained this. Artifact artifacts means that I was saying that some ED current and the heating will generate and all and all. So it is true or false? Just I explained.
False.
Yeah, this is false because it won't affect. That's why we use this as a. That's why we can use this as a bone implants during the MRI because it won't get heat up. Okay, so in here, yeah. So in general, carbon is considered MRI salient, which means it does not interfere with electromagnetic field to produce artifacts. Okay, so when there will be in MRI, electromagnetic field will be there, so the ED current will generate. So carbon has a low electrical conductivity, hence low ED current are produced. So likewise, suppose if you are using this as a bone implant and the low ED currents will be produced, so less heat up will be there. So if less heat up will be there, then it will be a better for your patient, right? But if you are using any metallic, let's say a titanium or the other implants you are using, and there will be a electromagnetic field will produce artifacts, right? So there will be a high conductivity and that will generate a high ED current. So because of this high ED current, your um, heating will be more, right? So that's why carbon based this bone implants will be a better for your MRI, can be used for making bone implants. Patients can undergo MRI. Is it clear to you guys that why we use this as a bone implant?
Yes.
Okay. Different isotopes of carbon have the same number of electrons but different number of neutrons. So it's just from the definition, just I explained you this. So true or false? Same number of electrons, different number of neutrons. Just see and tell the answers quickly.
True.
True. Yeah. So here you can say a same number of protons and the different number of neutrons are there. So isotopes are that you will have a same number of electrons and protons and the different number of electrons. So radiocarbon dating can also be used to determine the half-life of inorganic fossils. Can you determine about the half-life of inorganic fossils by radiocarbon dating?
False.
Why?
It's carbon dating, na? So carbon needs to be present. Half-life of inorganic fossil would be like,
Yes,
first of all,
yes,
inorganic fossil means what?
yes, true. So radiocarbon, that's yeah, carbon is not present there. Then how can you determine? It is basically right. Radiocarbon dating is what method used for determining the age of fossils, right? So carbon must be present there. Archaeological object using carbon 14. So here carbon 14 is used. So so when the living object, so let's say we as a human being are consuming organic material, food and etc. There is some carbon 14 intake. But since the body is alive, it gets rid of that food and the human consumes new foods. So carbon 14 keeps getting replenished, and its concentration is pretty similar to atmospheric concentration. After that, the body stops all its processes, so the concentration doesn't change further. Okay, so that will valid for all living things. So here this is a radioactive. So there are some calculations. So some half-life calculation here you can see. So yeah, so this is mainly radioactive dating is not for the inorganic, it is for the organic. Okay, so here you can see uh, the inorganic material cannot be dated, and also the last 100 years the carbon concentration had drastically increased in the atmosphere, and yeah, these are some limitations. You can find it in the slides. One can change the properties of carbon materials by tuning the manufacturing parameters. This I said. Is it true or false?
True, sir.
True. So can you give any example that how can we change the this menu properties of by changing or tuning the manufacturing? Just I have shown you this graphene photo if you are present here. So just very simple. If I will, let's say I will have a graphene and I will have a graphite. So the manufacturing parameters are different for both, right? So there will be a change in the property, right? In graphene and graphite. So if I will tune my manufacturing parameters, I can change the property. Is it all right? Huh?
Yes, sir.
I know it's time for the dinner, but so I also uh, try to finish, but actually the 2 hours is very you know large, and the session is for 2 hours. So we also have to make a recording and for 2 hours. So I know it's quite hectic. So carbon is hard and brittle. So if I will say hard and brittle, then you will say it's a ceramic. So do you really think carbon is ceramic? I will say let's hard and brittle. So is it a ceramic? Huh? What is your comment? Carbon is a ceramic? I'm not saying anything. Are you guys there or left? Am I talking to myself? Okay, only 3 persons left. Okay, I will. If you guys want, you can also leave. You may leave. I will just hold it till 9 because I have to submit the recording. So, are you guys there?
Yeah, sir.
So,
Yes,
do you think carbon is a ceramic?
I think so. It's false.
Okay,
false.
false. So, carbon is not a ceramic. On the just basis of a hard and brittle, you can't say because I have listed a many property of a carbon, right? You can tune the property. So, if it is a ceramic, then it can't be a conductive. Ceramic is not a thermal or the electrical conductive thing. So, it can't be a ceramic, guys. Okay, so it is a false. Again, disordered material contains only crystalline resin. True or false? If I will, let's say I will give you a disordered material. So that only contains a
It's
crystalline.
false.
Huh?
False.
False. Okay, it can contains non-crystalline reasons also. So that is false. So yeah, guys. So somewhere we are, uh, about to end this session, and yeah, it's quite hectic session for you and for me also, but we can't skip. So is it guys okay the way I'm going and explaining, or you want something more, to me for implementation?
A small request from my side, sir. If possible, can you able to share that this presentation, sir?
Huh? What?
If possible, can you able to share this presentation, sir?
Sure, I will share. So what I will give you, I will write my email ID in the chat box. So there
Okay.
you can, so I have written my email ID in the chat box, Gmail ID.
Yes, sir. Yeah.
So you can get it from there, and whenever you have something, I can share for this slide.
Thank you.
Anything else? Anybody else wanted to ask me something?
Sir, can you please try to discuss any problematics?
Problem?
Yeah, sir.
Which problem?
Actually, in week 1, we have a problem which is not dealt in the session.
Okay. So what I will
So,
suggest you also, let's say, suppose I have given my email ID, Gmail ID. So you can also send me some queries in this mail, and what we can do also, you can come up with your questions, and you can also prepare some slides where you will the questions where you will have some doubt or something you wanted to discuss, and then we can freely discuss in the next session. So because it was my next session, so I was not aware and about your assignments question, because we are just instructed to deliver a lecture which is on the basis of your weekly module. So I try to collect some questions from here and there, and I just simply explaining, so that it is the main concept, or the main motto of this session is to understand that module, and that will help to learn your assignment. So that's the main objective of this session. Okay.
okay, sir.
Yes.
Okay. So yeah, feel free to ask me. You can mail me. You can put up a question in my mail, and you can discuss it in the next session. I'm okay to discuss it. Okay. So what about others? Vikas, do you have any question?
No, sir.
No? Okay. So is everything all right? Then you guys may leave, and thanks for coming. Thanks for joining.
Thank you.
Thank you, sir.
Thank you, sir.
Yeah.